Welcome students. Now we are going to discuss multiple choice questions which are helpful for university examinations and for various entrance and competitive examinations. In this video, multiple choice questions of NMR spectroscopy are solved with explanation. So let us start. Question number 1. The compound CH3CH double bond CH2 gives how many signals in NMR spectra? Options are like this: 2, 3, 4 and 6. In this compound there are 4 set of protons: CH3CH double bond CH2. In that case, these are the 4 set of protons. This is methyl group proton, this is another CH methyl group proton, and that CH2 group protons are not equivalent as there is a restricted rotation due to double bond, and therefore that C and D protons are the different set of protons, and as there are 4 set of protons, it gives 4 signals in the NMR spectra. Therefore, the correct answer for this question is 4. Then question number 2. In compound CH3 thrice C, CH3 thrice gives how many signals in the NMR spectra? When we look the structure of this compound, the structure of the compound is like this, and in that case all methyl group protons are equivalent. And as all methyl group protons are equivalent, they form one set of proton and they gives one signal in the NMR spectrum. All methyl group protons have similar chemical and electronic environment, therefore they form one set of protons and they gives one signal in the NMR spectrum. Therefore the correct answer is 1. Then next question number 3. The signal obtained at 1.8 delta ppm having instrumental frequency 60 MHz, what will be its chemical shift value in Hertz? This is the chemical shift value in delta ppm, and we have to calculate the chemical shift value in Hertz, and we know that at 60 MHz spectra, 1 ppm, 1 delta ppm corresponds to 60 Hz. Therefore, as 1 ppm corresponds to 60 Hz, 1.8 ppm corresponds to 10 Hz. Therefore, the correct answer for this question is option B, 108 Hz. Question number 4. The chemical shift range for aromatic protons is dash dash delta ppm, and in case of aromatic compounds, the characteristic chemical shift value is 7 to 8 delta ppm. This is because in case of aromatic compounds, when such compounds are placed in applied magnetic field, protons present on aromatic ring, they are present in deshielded zone, and due to anisotropic effect, aromatic protons are in deshielded zone and they have the characteristic chemical shift values between 7 to 8 delta ppm. Therefore the correct answer is D, 7 to 8 delta ppm. Then question number 5. The compound having molecular formula C6H12 gives singlet in NMR spectra. Which of the following is the correct structure of the compound? This is option A, this is option B, this is option C, and this is option A. In that case, while solving the problem, C6H12, we have to calculate how many sites of unsaturations are there. And the formula C6H12 have one site of unsaturation. That is, this compound is not saturated. Therefore, option C and option D are the incorrect answers. Between A and B, which is the correct structure? In case of structure A, it is the structure of cyclohexane, and in case of cyclohexane, the ring is not planar, and as ring is not planar, it has the chair form, which is the more stable form, and in that case there are two sets of protons, axial protons and equatorial protons. But in case of option B, this structure contains 4 methyl group protons, and all 4 methyl group protons are equivalent. That is, all 12 protons are equivalent, and they give singlet in the NMR spectra. Therefore, the correct answer is B, that is, this is the structure. Then next example, question number 6. The TMS is used as internal standard in PMR spectroscopy due to, and the reasons are like this: its protons require higher magnetic field strength for resonance, it is soluble in organic solvent, it is chemically inert, and all of these. And we know that the TMS, that is tetramethylsilane, it is used as internal standard, and tetramethylsilane has the structure like this, and in that case silicon is less electropositive than carbon, and all methyl group protons are highly shielded and equivalent, and they give the single sharp singlet in the NMR spectra, and it is also chemically inert. Therefore, all these 4 options are correct, and thus the correct answer is all of these. This is the answer for question number 6. Then next question, question number 7. In the PMR spectra of CH3 CH2 CHCl2, methylene group proton gives what type of signal? And in that compound, this is the structure of this compound, and we have to determine the signal of methylene group proton. And according to N+1 rule, for methylene group proton, there is only one adjacent non-equivalent proton. On this side, there is no proton on this carbon atom, and as there are only one non-equivalent adjacent proton, therefore, according to N+1 rule, it gives doublet in the spectra. Therefore, the correct answer is B, that is doublet. Then next question, question number 8. In case of ethanol, the coupling between methyl and methylene group protons is of the type dash dash coupling: geminal coupling, vicinal coupling, long range coupling, or all of these. In case of ethanol, methyl group protons are adjacent to methylene group protons, and methyl and methylene group protons are not equivalent, and there is a coupling between methyl and methylene group protons. And methyl and methylene group protons, they are separated by 3 bonds, that is 3J. There is a 3J coupling, and these protons are present on adjacent carbon atoms. Therefore, that coupling is known as vicinal coupling. Thus, in case of ethanol, the coupling between methyl and methylene group protons is of the type vicinal coupling. Question number 9. In para-dichlorobenzene, it gives how many signals in PMR spectra? Options are like this. This is the structure of para-dichlorobenzene, and it is a symmetrical molecule. And as it is a symmetrical molecule, these 4 protons on benzene ring are equivalent. They have similar chemical and electronic environment. And as all these 4 protons are equivalent, they gives one signal in the PMR spectra. Thus the correct answer is A, that is 1. Then question number 10. The splitting of proton signal takes place due to dash dash between non-equivalent protons. Options are like this: magnetic interaction, force of repulsion, magnetic opposition, and force of attraction. When protons are non-equivalent and if they are present on adjacent carbon atoms, the splitting of the signal takes place, and that splitting of the signal takes place only due to magnetic interaction between non-equivalent protons, and that interaction passes through electrons of intervening bonds. Thus, splitting of signal takes place due to magnetic interaction between non-equivalent protons. Question number 11. In which of the following molecule methyl group protons gives the most downfield signal? When proton is present on the carbon atom which is further attached to electronegative atom, then due to electron withdrawing inductive effect, deshielding of the protons takes place. In all these compounds, in compound A, the OH group proton and methyl group protons are well separated. They are separated by these 4 carbon atoms. In structure B, they are separated by 2 bonds. In structure C, they are separated like this. There are 3 carbon atoms. They are separated by 3 methylene groups. But in case of structure D, the methyl group proton is directly attached to hydroxy group proton. Therefore, due to electron withdrawing inductive effect, the effect is more in compound D. Therefore, in case of compound D, the methyl group proton is highly deshielded and it gives the most downfield signal. Question number 12. In 60 MHz spectra, the proton signal is obtained at 3.1 delta ppm. In 300 MHz spectra, the signal of this proton will appear at dash dash delta ppm. These are the options, and the explanation for this question is when chemical shift values are measured in delta scale, then these values are independent on applied magnetic field strength. That is, they are independent on instrumental frequency. And as they are independent on instrumental frequency, if the signal is appear at 3.1 delta ppm in 60 MHz spectra, then in case of 300 MHz spectra also this signal will appear at 3.1 delta ppm. That is, chemical shift values are independent on instrumental frequencies. Question number 13. In 1H NMR spectra, the proton HA couples with a proton having coupling constant 5 Hz, and it also couples with other 2 protons having coupling constant 10 Hz. Then the signal of HA have multiplet of dash dash lines. The options are 4, 6, 5 and 8. And the explanation is when a proton couples with other set of protons, then splitting of signal takes place according to n+1 rule. When proton HA couples with 2 protons, then signal split into 3 lines. That is, triplet is obtained having coupling constant 10 Hz. Also, proton HA couples with a proton, then each line of triplet is split into 2 lines having coupling constant J is equal to 5 Hz. And thus the signal of HA have multiplet of 6 lines. It is shown like this. The HA proton couples with two protons having coupling constant 10 Hz, we get the triplet. It also couples with a proton having coupling constant 5 Hz. Then each line of triplet is then splitted into two lines, and then we get 6 lines in the multiplet. That is, signal is splitted into 6 lines. This is the correct answer. Then question number 14. Ethylenic protons are more deshielded than acetylenic protons due to, options are like this: anisotropic effect, sp2 hybridized carbon is more electronegative than sp hybridized carbon, sp2 hybridized carbon is less electronegative than sp hybridized carbon, and due to deactivation of ethylenic protons. The answer is like this: in case of ethylenic protons as acetylenic proton, there is a anisotropic effect is observed, and due to magnetic anisotropy, ethylenic protons are present in deshielded zone while acetylenic protons are present in shielded zone. That we have studied in the shielding and deshielding. Although in case of ethylenic protons, the carbon is less electronegative, but acetylenic protons, they are present on sp hybridized carbon. Although they present on more electronegative carbon, due to anisotropic effect, acetylenic protons are present in shielded zone, and it is observed that ethylenic protons are deshielded. And thus the correct answer is anisotropic effect. That is, due to anisotropic effect, ethylenic protons are more deshielded. The next question is question number 15. When electron donating group is present on benzene ring, then chemical shift value of aromatic protons is whether it is more than 7.27, less than 7.27, less than 4.0 delta ppm, or it always equal to 7.27 delta ppm. And remember that the chemical shift value of benzene is 7.27 delta ppm. If electron donating group is present on benzene ring, then due to electron donating effect, it donates the electron density to benzene ring. And as there is an electron donating effect, the shielding of aromatic ring protons takes place. And due to shielding effect, the chemical shift value of aromatic protons decreases. And thus, the chemical shift value is less than 7.27 delta ppm. Question number 16. The compound CH3CH2 thrice COH gives how many signals in NMR spectra? The structure of this compound is like this: CH3CH2 3 times and is attached to OH. In that case, there are 3 sets of protons. CH3CH2, all these CH3CH2 protons are equivalent as they are attached to same carbonate. But there is a set of methyl group protons, the another set is of methylene group protons, and third set is of OH group protons. Therefore, as there are 3 sets of protons, it gives 3 signals in the NMR spectrum. Then question number 17. The compound having the molecular formula C10H15NO have dash site of unsaturation. Options are 1, 2, 4 and 0. The answer is like this. The molecular formula of the compound is C10H15NO. While calculating site of unsaturation, the oxygen present in the molecular formula, it is neglected and the nitrogen is replaced by CH. Then the above formula becomes C11H16. The corresponding saturated formula is C11H22. According to the formula, Cn H twice n plus 2. And between these two formulas there are 8 hydrogen atoms less. 24 minus 16, that is equal to 8, and the site of unsaturation is equal to number of hydrogen atom less divided by 2, that is 8 divided by 2. The answer is 4, and therefore for this molecular formula there are 4 site of unsaturations. Question 18. The instrumental frequency of 100 MHz corresponds to dash dash magnetic field strength. And we know that for 60 MHz spectra the magnetic field strength is kept at 1.41 Tesla. This is because at this magnetic field strength the proton comes under resonance. That is, at magnetic field strength 1.41 Tesla, proton resonate at 60 MHz. Its resonance frequency is 60 MHz. And as 60 MHz corresponds to 1.41 Tesla, therefore 100 MHz corresponds to 2.35 Tesla. Tesla is the unit of magnetic field strength. Similarly, 300 MHz corresponds to 7.02 Tesla. In this question, for 100 MHz spectra, the magnetic field strength is 2.35 Tesla. This is the correct answer. Then question 19. Which of the following compound gives signal at 1.1, 2.4, 11.2 delta ppm? And we know that when the signal is between 11 to 10 delta ppm, then that signal is for COOH group protons. Therefore, answer B and D are incorrect answers. Between A and C, we see that one signal is 1.1 delta ppm and the another signal is 2.4 delta ppm. And these two signals are possible in case of structure C, because 1.1 for this methyl group proton the signal will appear at 1.1 delta ppm. In case of structure A, that methyl group proton the signal will be near about 2.0 delta ppm. This is the explanation for this compound, and therefore the correct answer is C. Then question 20. The compound having molecular formula C4H10O gives two signals of relative intensity 9 to 1. The correct structure of the compound is like this. In that case, the relative intensity of the proton is 9 to 1. Therefore, in case of structure C, structure B and structure D, these are the incorrect answers. And in case of compound A, there is a proportion of 9 to 1. And in that case, there are two sets of protons. One is of methyl group protons and another is hydroxy group proton. And as the relative intensity is 9 to 1, the structure A is the correct structure for this question. The relative intensity of quintet is, these are the relative intensities, and the relative intensities are calculated by Pascal's triangle. For singlet it is considered as 1, for doublet it is 1 to 1, for triplet it is 1 to 2 to 1. It is obtained by that diagonal summation 1 plus 1, that is equal to 2, and always in the multiplet the outside intensity is always 1. In case of quartet, the relative intensity is 1 to 3 to 3 to 1. 2 plus 1 is equal to 3, 2 plus 1 is equal to 3, and the relative intensity is 1 to 3 to 3 to 1. Therefore, in case of quintet, the relative intensity is 1 plus 3 is equal to 4, 3 plus 3 is equal to 6, 3 plus 1 is equal to 4, and their outsider is 1. Therefore, in case of quintet, the relative intensity is 1 to 4 to 6 to 4 to 1. And thus the correct answer is C, 1 to 4 to 6 to 4 to 1. These are the questions on NMR spectroscopy. Thank you for watching this video. Always keep learning.